All right, hi guys. It looks like the most voted on question for you guys was questions 3 and 4 on part 2. So right now I have those up. These are imaginary numbers as well as, actually both of these are just imaginary numbers. So what I noticed about question 3 is that that's a binomial. Typically with binomials, we solve them by FOILing or multiplying. So I multiply the first two terms, the outside terms, the inside terms, and the last terms. If I multiply those first two terms, I'm going to get 6i. If I multiply the outside terms, it's going to be minus 8. If I multiply the inside terms, it's plus 18i squared. And if I multiply the last two terms, it's minus 24i. All right, there's a note down here to remind you that I squared is the same thing as -1. So anytime I see an I squared, I'm going to replace it with -1. So what we're saying here is we have 6i minus 8, and then this becomes 18 times -1, so that's minus 18, and then minus 24i, and then I can combine the like terms, so -8 and -18, and then 6i and -24i. They want you to write it in the form a plus bi. What that means is that the real number should come first. So the real number would be -8 minus 18, which is -26. And the imaginary component is written second. So that is choice A. All right, for problem number 4, this is also an imaginary numbers problem. If you can recall from Algebra 2, there were different powers of I that you could reduce. So I'm going to start with if something is I to the first power, that's I. I squared, we've already talked about in the previous problem, is -1. I cubed could be broken up into I squared times I. I squared is -1. So then that's going to be -i. And then I to the 4th is the same thing as saying I squared times I squared because we use our exponent properties. So if I add the 2 and the 2, I get I to the 4th. I squareds are -1, so this is -1 times -1, and that's +1. If I were to go any further than I to the 4th, so for example, if I showed you I to the 5th, I could rewrite that as I to the 4th times I to the 1st, because again the exponents would add up to I to the 5th. I to the 4th I can replace with 1, so this would be 1 times I, or I. So notice that we're getting the same answer that we started with. So I only really care about these 4 variations of I. And so basically what I'm going to do is I'm going to take the exponent of higher power, so this one's kind of hard to see, but that's a 48, and I'm going to try to see if that is divisible by 4. Because if I look at the one that has a power of 4, that's the easiest one to simplify because it just becomes 1. Okay. So if I were to take 48 and divide it by 4, it divides by 4 evenly. I'd get 12. So because it's divisible by 4, that means that it's going to break down to 1. Okay. So this would be 1, but then there's a negative sign in front, so it's really -1, or C. Okay. I'll give you another example to help make more sense. Let's say I had -I to the 46th. Now 46 is not divisible by 4, but if I break it up, the closest exponent or number that would be divisible by 4 that's close to 46 would be 44. I'd have 2 left over. So this one's just going to reduce to 1. So 1 times I squared is like 1 times -1, or -1. I'll remove this negative out in front just to make it less confusing. All right, so that's how these problems work. If you guys have any additional questions, just let me know or email me. You guys have been doing a really good job so far. We're almost done with this SAT unit, and then we'll be moving on to probability. All right, have a good